Welcome back. Today is day 6 of our Introduction to Circles unit. We will be solving a challenge problem today involving an inscribed 5-pointed star. We will be using Geogebra to investigate this problem and then proving our findings. Hope you enjoy the video. Alright, let's try to build that inscribed star that we just looked at. So I'm going to place 5 points. So I'm going to click on the point tool right here, and I'm going to place 5 points on the circumference of the circle. So 1, 2, 3, 4, and 5. Perfect. And then I'm going to use the segment tool. So I'll scroll down a little bit and find the segment tool. And I'm going to connect each one of those segments so it makes a star. So I think I need to connect here with here. This looks good right there. Let's connect F to D and then E to G. And then we'll connect across G to D. And there we go. We have created an inscribed star. Very nice and simple. Alright, now we need to find the measure of each one of the angles. So we're going to go up here where it says measure, and then we'll find the angle tool, and then we'll click on, you can click two different ways. You can click on the points, so E, then G, then D, or you can just click on the two sides. So I'm going to just click on the sides of my angle. So here, and perfect. And you should know, if you miss, you might have to go back and do it again, or if you click in the wrong direction. So this GeoGebra pays attention to direction. So you see I clicked on the right side and then the left, and it measured the outside of the angle. That's not what I want, so I'm going to go back and then I'll try it again. So I'm going to click on this side first and then this side, and there we go. And now I can quickly go through and find the measure of each angle. Look how fast this is. This is very nice. Perfect. And bam. So now if I want to see them better, let's click the move button and let's move these angles around a little bit. So this angle is, the variable for this angle is alpha, so that's going to be used in a little bit. Here, this one's beta. I forget what this one's called. And this guy, I forget what he's called also, or she's called. And this one here, I believe that's sigma. Alright, so we're going to find the measure of this. But now the cool thing is, if I move these points around, you can see some of the angle measures are changing. Alright, and so your job was to figure out what is the sum of these 5 angles. What do they add up to? So let me show you another cool little trick. The cool thing about GeoGebra is if we click on the calculator button up here on the top left, it'll show me all the stuff I've created, but also I can add inputs in. So let's create a variable. How about we say sum is equal to, and then we're going to use these angle measures. So I'm going to use these angle measures and find the sum of those. So to find them, you have to click on the keyboard. So here on the bottom left, the keyboard will pop up, and if you can't find what you're looking for, you might have to click around right here. But you should see my variables pop up. Here they are. So if I click on the variables, now I should be able to add these in. So here we go. Let's go with this one. Let me scroll down so you can see what's going on here. So I got alpha plus the next variable, which was, there we go, plus the next variable, which is it this one? Is that what I'm looking for? I believe so. Well, let's see if that works. Plus the next variable, which is what? Can't see. And still can't see. There we go. Plus, there we go. Let's see if this works. Plus the last one and this one I'm looking for. Let's see if this works. Oh, perfect. So when I add those variables up, all these 5 variables, look what happens. It's beautiful, but in this problem, they add up to 180. And if I move this around, so we can see the values of all those angles changing. or not all of them, but some of them changing. But what do we notice what happens with the sum? So we look at the sum here, and the sum is not changing no matter what I do with this. Nope, it's not changing. Nope, it didn't change. Nope, it didn't change. So what this app is showing us right now, it says that these 5 angles are going to add up to 180. And I like this because no matter how I build this, I could kind of build it really close to the top. And there's my star right there. And it still equals 180. When you add these up, it's still going to add up to 180. All right, so now let's actually go ahead and try to prove that now. That's where we're going with this. Let's try to prove that all those 5 angles add up to 180. Found out on Geogebra. So again, I'm going to write down every time you have a proof, you're going to have a statement that it's going to say prove something. So for this one, we're going to prove that A plus B plus C plus D plus E is equal to 180. So this is what we're trying to prove. Okay, we're trying to show that no matter what happens, every time we add these angles up, A plus B, A, B, C, D, and E, we add those measures up, we should get 180. All right, now, first thing we're gonna do, we usually always have a picture. If you don't have a picture, I would sketch one out. So on this problem, we have a picture, so we're good there. Now we're gonna have to look at this and start saying, okay, what do we notice? Well, the first thing I noticed is that these are inscribed angles. So I'm just gonna write that down, and we're gonna use a flowchart proof today. So in this problem, we're gonna say, how about we give some letters here? Because that will help us out a lot. So let's call this A, let's call this B, C, D, and E. So now we have some points here. So these are point A, point B, and point C, and now we can name those angles accordingly. All right, so let's start off with the first one. Angle, whoa. So angle A is an inscribed angle. So here's the first thing I know. And every time we do a proof, we're going to have a statement and a reason. So the first part's a statement, and then we're going to have a reason. And how do we know that? We know that because it was just given to us. It's just given to us in the picture. So we're going to write, okay, this is given. And when I do my proofs, I'm always going to do them, when I do my flowcharts, I always kind of do them in little boxes. So here we go. Here's the first one. So we know from this picture that angle A is an inscribed angle. But we can say the same thing about angle B, the same thing about angle C and D and E. So I'm going to go ahead and write those down. I'm going to jot those down. So angle B is an inscribed angle. Sorry, I'm trying to write small so I can fit everything in there. And how do we know that? Because it was given to you. All right, perfect. So we have 2 of them down. I've written down 2 of my statements, and I'm not gonna be able to fit in the rest, so I'm gonna have to write small for this next part here. I'm gonna have to abbreviate some things. So angle C is an inscribed angle. Perfect. I'm just gonna leave it like that, and that's gonna be a given. You should be writing it all out in your problem, so that's given to us also. Now we need to fit in this little space right here. We need to fit in D and E. So I'm running out of room. So I'm gonna have to go a little smaller. So angle D is an inscribed angle. That's given to you also. All right, these boxes are getting smaller and smaller. And the last one, we made it. Angle E is an inscribed angle. Perfect. We just fit everything in there, and that's given to you also. So it was given to us because it was just given in the picture. So just by looking at the picture, we can see that each one of those are inscribed angles. Now I really like flowchart proofs because it kind of tells us exactly, like, if they tell you something, then you can infer something else. So now, what can we conclude then if A is an inscribed angle? So let's take a closer look at angle A. So here's angle A, and it tells us that this measure is A. But now you should be able to figure out some kind of relationship between the arc, this intercepted arc. So what's the measure of this arc CD? Now remember, when we learned about inscribed angles, we knew that the arc is twice the measure of the angle. So I can say in this problem right now, I can say that the measure of arc CD is equal to 2A. Does that make sense? All we're going to do is double whatever the angle was, and we're going to get 2 times A, which is 2A. So this arc is 2A. Perfect. And how do we know that? That reason we're going to say is going to be the inscribed, I'm going to abbreviate inscribed angle theorem. And if you don't know the exact name, if you just said, well, definition of inscribed angles, I would be okay with that too. Okay, because we kind of know it like a definition now. We know that our inscribed angle is going to be twice as large, or half the size of my arc, or the other way around is double the angle. All right, so let's go with the next one. Let's see if we can figure out the next one. So you'll see in the next part here, we are given this angle B. The measure of this angle is B. And if we double that, we will get this arc over here. So we know this arc is going to be 2 times B, which is 2B. So perfect. So then I can write over here the measure of arc DE is equal to 2B. Perfect. And how do you know that? Same reason as before. Inscribed. I'm just gonna put little colons here, so that way I don't have to fit it all in there. So we know the same reason because of the inscribed angle theorem. All right, and we can do the same thing for all of them. So look how nice and neat this works out. Let's go with the next one. This angle right here, has a measure of C, and we know this intercepted arc right here is going to be twice as large as that angle. So we know this is 2C. So let's go ahead and write that in. So the measure of arc AE, it looks like, is equal to 2C, or C times 2. All right, and the same reason. It was inscribed angle theorem. So now, and what I like is that these are telling you these. So again, hopefully you see the connection. Angle C is an inscribed angle. So angle C is an inscribed angle. That means we know the arc is twice as large. All right, angle D, let's go look at angle D. Angle D, this angle measure has a measure of D, which means we know that this arc over here is going to be 2 times D. So perfect, so I can write that one in. So the measure of arc AB is equal to 2D, and I'm running out of room again. What's your reason? We need a reason. Same reason. Inscribed angle theorem. All right, let's see if we can fit this last one in here. This last one we're going to go with, how about we go with, what color have we not used yet? Have we used red? No, we haven't used red. Perfect. So this is angle E. The measure of this angle is E, and we know that this is going to be twice as large. So double it gives us 2E. So let's write this one in. So the measure of arc, we're getting smaller and smaller. We keep running out of room. BC equals 2E. So doubling that value. All right, and the reason is going to be the same reason, inscribed angle theorem. A lot of times this happens where you use the same reason over and over for each problem. Okay. Now, so hopefully you see what happened here. Because each one of those were inscribed angles, we just doubled the angle to find the measure of the arc. Now you should see a relationship happen here. So I see that the blue arc and the green arc and the pink arc and the orange arc and the red arc together complete a circle. So that should tell me now that I'm going to use just one color this time, that 2A plus 2B plus 2C, and we're going to write them all in, has to equal 360 degrees. So I know that if I add all the measures of those arcs, they have to equal 360 degrees. Now, how do I know that? Well, that's just going to be because it's just the definition of a circle. If you wrote that, I'd be happy with that definition of a circle. We know that all circles, the measure of the whole complete circle would be 360 degrees. So again, what I need you to understand though was these 5 statements help complete this statement. So this last statement that we just wrote down came from knowing those 5 statements right there, knowing that we saw that each one of those arcs completed a whole circle, and then we just used that little piece right there. Okay, so now let's finish this up. We're almost done. Hopefully you notice that each one of those arcs, each one of those, so 2A, 2B, 2C, 2D, they all have a 2 in it, so we're going to use a little bit of algebra, go back to like 3rd grade, and remember we can factor out a common factor, so we're going to get 2A plus B plus C plus D plus E is equal to 360. And this is called, back to 3rd grade, when you first learned this was called the distributive property. Okay, so that was the distributive property. Boom. Okay, usually we did it the other way around. We actually multiplied the 2 through, but we can also use it to go backwards. Alright, so we use the distributive property, and last, hopefully you see what happens here. We can divide both sides of this equation by 2. I'm going to write it in, and I'm going to erase it. I know I can divide this side by 2, and I can divide this side by 2. So we can do that, but I'm going to erase it because we usually don't write that step in. We just say we did it. So in this problem, we're going to get A plus B plus C plus D plus E is equal to 180. Because when we divide by 2, the 2's cancel out, and the 360 becomes 180. And the reason that we used our division, it's called the division property of equality. I'm just going to abbreviate it right there. Okay, meaning, think about it how you learned it back like in algebra when you first started studying algebra. Whatever you do to one side, you have to do the other side. Remember, we did that many times. So if we divide one side by 2, we have to divide the other side by 2. That's just using the distributive property of equality. And now, look what we have done. This right here, this statement, A plus B plus C plus D plus E equals 180, is what we were trying to prove from the get-go. We were trying to show that, guess what? A plus B plus C plus D and E have to add up to 180. So again, this is what we call doing a proof, and we can write it up different ways. We can write it up in a 2-column proof if we want to, or even a paragraph proof from here. All right, but again, I like flowcharts because they show us exactly how, like, what's connecting to what idea is connecting to another one. All right, well done.